Hello everyone, my name is Hardeep and you are on the Kubernetes show. And today we are continuing our work on CKA certification. So if you are new on my channel, welcome. I am recording two courses altogether. One is on Linux, getting started with Linux. That is for somebody who is getting started, very new to whole cloud and this technology world. And the second one is for someone who has experience on containers and want to get the Kubernetes certification. Uh, so you can go on github.com and go to the Kubernetes show, and you'll be able to see two repositories. One is focused on Kubernetes and another is focused on Linux. So if you get into the repo of Kubernetes, you'll see some getting started guides, and finally you can click on this CK exam. uh, if you see, there are some videos that I recorded before aligning my course with the curriculum 1.33. So today we are working on workload and scheduling. This is the second link. There is already a video recorded for some of the concepts, which I recorded on July 13. So today we are looking into deployments, how to perform rolling updates, uh, then self-healing of applications, configuring auto scaling for workloads. We look into config maps, we look into secrets. We will also look into some of the tools that are available for templating. All these topics are covered as part of CKA exam requirements. Most of the things you'll be doing during the exam need to be imperative. You should be running commands on the fly, kind of generating code as quickly as possible, because time is the limiting factor during this 2 hour exam. You have number of questions that you need to solve. Let's get started. So what is a rolling updates, and how do we kind of roll back the changes, right? So in my previous video, which I was talking about, there are two videos on the same topic. In the previous video, I talked about, how deployments work and what is the difference between declarative and imperative. The way deployment functions is it is a superset of replica set. So with replica set, you are maintaining, let's say you said you want three replicas or three pods of Nginx running, right? So that is the responsibility of replica set to manage and maintain them. But this kind deployment is responsible for versioning, allowing you to rolling updates, then restarts, rollbacks, right? That is what you get with deployment. So if we look at a normal deployment or even pod, right? So I've shown something here, .spec.template. You can go on Kubernetes website, search for example, this declarative management of Kubernetes objects. So there are different playgrounds. So today what I'm going to use is, maybe I'll use this code cloud playground, and it runs for 1 hour. That's the limitation. You don't retain anything that you kind of deploy there, right? That's why I'm trying to do it on my laptop. Anyways, getting back to the topic, right? So this is a deployment. How do you create deployment? You can basically apply a YAML file directly, like I'm doing here from internet. kubectl command is able to download and apply, or you could create a deployment file locally. Then you can say kubectl apply -f and name of the file, right? Those are two ways of doing it. Third way is you can say kubectl create deployment, give it a name, and then you specify some parameters that you could do on the fly, right? So all right, so I got this. Let me maximize this to okay. All right, so Let's try. Okay, get PO. Okay, nice. Okay, so K create deployment. You can do -h. If you don't remember the syntax, very easy. K create deployment and scroll little up in the output. You can see how you can create a deployment, and you are defining replica sets. You are also able to expose the port also, right? So look at this here. You can define multiple containers, right? So this is 1.34. So okay, version, yes, this is 1.34, and it has all the features like you can create a deployment with the multiple containers. One is busybox, another is ubuntu, right? All right, so coming back, so this is our deployment. What we're going to do is we're going to deploy it as it is. Okay, all right, so that's my laptop, things getting deployed. Let's see. All right, so I kind of ran something directly from Kubernetes website, which the content from GitHub. And if we look at get deployment, we can see we are running three of the replicas. This is exactly what you see here, right? So if you want to see the content of this, you can do curl hyphen L. If we have curl, you can see, right, it is something similar, right? So you got three replicas. It is running on container port 80, right? And you want to check the status of the replica, you run rollout status, or you can do k get deployment. So the short form for deployment is deploy. It is taking time, I don't know why. K describe deploy. It shows there were three desired and three are up to date. Total three are unavailable, none of them is unavailable. You can see the labels, you can see, annotations. All that information is available here. It talks about the port and host port and other details. Even you get the events. How do you make changes on the fly? So this was something we deployed using kubectl apply, right? So let's try something. Kubectl k create deployment, my deploy hyphen image. Let's see what version of image it is using. Okay, it is using this. Let's set it for to the same version here, right? All right, k get deploy, and we can see it created one deployment for me, right? So k scale, all these commands like I just ran, you should be able to do it on the fly during the exam. K scale deployment, and name of the my deployment replicas 5. Okay, now k deploy, you can see ready one, and total 5 are required, right? So you can get the status of it like this. So get my deploy, right? kubectl rollout, and it says successfully rolled out. And if we check the status, there are 5 out of 5. How about if we say 20, right? Let's see what is the status, right? Rollout status, it says it is deploying, it is waiting for it to finish kind of making 20 containers. This environment is limited because we are running on internet somewhere, so it might not be able to do it, but looks like we have enough resources and it was able to scale. So we have 20 nginx running there, right? So version 1.14. So what are the benefits of deployments that we were talking about, right? uh, One benefit was rolling updates, and you can see how on the fly we are setting the image to 1.16.1. So for this deployment we are changing the image. So if I run this and then look for the Nginx deployment status, you can see it has updated one, then it'll update it second, then it'll update the third one, right? How does that get handled? So it is kind of deleting the old replicas, right? So k get deployment, and let's look at this -o YAML. And why did it do one at a time? This is what is the reason for it. So your strategy by default is rolling update. So you are allowing maximum search 25% of the pods to kind of get updated, maximum unavailable 25, and type is rolling update. So one get updated, then second, then third, and then that is how kind of previous versions get deleted, right? So if we do deploy, you can see our pods are running, and here 20 are running, right? So if we want to do the same for our deployment called my deploy, it'll go like this, right? So one thing to note, this name need to be same that was inside this, because within your deployment you can have multiple containers, right? So which container this image will get updated, it depends on this. If your name matches, the container name matches, that's what gonna get updated, right? So when I say multiple containers, so if you recall, I was showing you this deployment -h. Here you can see image busybox, image ubuntu, right? So if something is deployed like this, you will have to specify the name accordingly, then only it'll get updated, right? So you got one, two, then three. You got three containers inside this deployment, right? All right. So we just changed that, added changed the version for it, and we can check the deployment status. Similarly, if we look for my deploy, you can see it is successfully rolled out, right? So does it let us just roll out, or we can do something more than that, right? We can do undo also. There is an option called undo. So what if you don't know what are options there, right? kubectl rollout -h, you can see it tells you there is undo, there is status, restart, and then you can do restart of a deployment that matches a particular label, right? So what we're going to do right now is test a deployment, which is this one, and we'll undo deployment, this one, nginx deployment. So what is it doing, what is it undoing, right? It is changing the image, right? So kubectl rollout status nginx deployment, it says it is successfully rolled out. So let's take a look at the output when I described it, right? So this was our deployment when I had set the image to version 16 something. You can see here image is set to version 16, right? So if I run same command now, what version do you think we will have? Version 14, right? How did it happen? It happened because of this undo. Okay, so how do we see history of rollout? kubectl rollout history deployment nginx deployment, right? So it says two of them, and when we are doing, when we are making these changes, like we were changing this image, there are some options that we can use to kind of record the changes too. I don't recall those options, but it is possible to do that as well. Let's see uh, if I can recall and add it. Let's see if we say rollout to revision 2. So what did it roll out to? What does that revision 2 means, right? So that revision 2 meant here the revision 1, revision 2, revision 3, revision 4. So when we deployed, that was revision 1. We changed it to go to version 16. That became revision 2. We rolled it back. That became revision 3. Now we again did undo of revision 3, and we said take it to revision 2. That means we went to version 16. So that is revision 4. Okay. This is how it kind of works, right? So let's see, if you are kind of doing the rollout and you in the middle of it you have thousands of parts. In the middle of it you found there were problems, you will do rollout pause. You troubleshoot it, fix the problem, update the things that you want to do, then you can do resume also, right? So there are ways to control it. Just in case to control the blast radius, you have options, right? Then history we already looked at, right? That was a bit about rollouts. There is at least one question in exam that says, reward your rollout to a particular version. So use this option hyphen hyphen 2 revision 2, right? Then I've given some links. If you click on these links, you'll land on the documentation page. You really need to know everything that is written on this website. You don't need to know by heart, but you should be able to figure out where should you go when during the exam you need to find something, right? So you this is where you will go and look for the information. What if you don't find information here, right? So you can use qk explain, right? kubectl explain, and then deploy, for example, right? Now it is telling you what are the options it has, and then deploy dot, let's say, kind, right? So in kind, what are the options there, right? Or let's say spec. There are thousands of options inside it, right? So you can do recursive, and then it shows you everything, right? So this is one way for me when I was doing my exam to structure my YAML file, right? Okay. All right. So next topic for us is, uh, our application self-healing. And how do we do all this, right? How do we know if our application is ready to receive traffic? When I did this, you know, when I scaled our deployment to 20, if you recall, I did this, right? Scale deployment 20, right? So in our deployment strategy, we had set it to rolling updates, right? 25% was set. So how does Kubernetes know if my pod is ready and healthy to receive traffic? The way I have done, like on the fly, it doesn't, right? As soon as your pod is created, it is kind of trying to send traffic, but you don't want that in production environments, right? So what's the solution? Solution is there are uh, some probes that you can implement. So those probes are liveliness probe, readiness probe, and startup probe. Now these probes are of different kind. One is TCP socket. There is HTTP type also, right? You can run command to basically answer, uh, right? So what's the idea behind is when your application starts, it might still be kind of reading through the metadata or setting itself up. You don't want to send traffic to this container which might get dropped, right? And your users might face problems. Solution to that is, first you look at the startup pro. this is kind of setting time. For example, failure threshold is 30 seconds, period 10, right? So period second, failure threshold is 30. It is 30 times it will fail, and seconds is every 10 seconds, right? So 10 seconds it is failing, then into 30, that is 300, that is about 5 minutes. So you are saying your pod will time out in a way, right? Like your startup probe will mark it as failed if it is not able to start even after 5 minutes. That is what startup probe does. Then second is readiness probes. Readiness probe is that monitors whether your pod is healthy and is able to respond to the request. So you can have it set like this. If your container started to respond to port 8080, this should be good enough for you, right? But at the same time, you might have a dependency on external service. For example, your pod is doing some transformation on the fly and it is dependent on a third party service. If it is able to fetch data from that third party service, then only it will listen on a port, for example port 8080, right? So that is readiness pro. Similarly, it has some seconds that you can define, and then it also has within period seconds too. Similar story. Then liveliness probe is during the life of container, when your container is running. Let's say you deployed your container today, and in 5 days something happens and your container is hung, it's no longer responding. How does Kubernetes know that your container is not healthy? Liveliness probe is what helps, right? So during exam, you need to know all this, all these options you need to figure out, right? What's the fastest way of doing it? Right? You pick up at least one name, no matter which one you do, right? Search it, and very first link, it takes you on this page, right? It talks about exactly same thing. Like I was saying, you have probes like liveliness probe, right? It is running a command cat and it is looking at the status of healthy. Okay. uh, so you are basically starting a script which is creating something, and all that is possible. You can, so one liveliness probe was exe type, right? Then you can have http readiness probe. For example, health z, this is very standard. Health z is kind of very standard way of doing things in Kubernetes. So liveliness probe on a path which is slash health z and port 8080, it is also looking for headers. It is not just doing curl to health z and waiting for an output from port 8080. It is looking inside and checking for headers. If there are headers of value awesome, then it is healthy, right? This is a good probe. Basically, it is not only going to a endpoint, it is also fetching some data from the endpoint, right? So this is one way of handling it. So basically it is looking for status 200, right? If you get okay or status 200, that is when it is healthy, right? And then TCP probe, readiness probe, that I was showing you in this one. This is TCP probe, right? All right. So then you have another probe of gRPC type. Right? Similar story. You can define a gRPC port, and you can have a probe for that too. Right? You can uh, use a named port, for example here, right? For the readiness pro, what I'm trying to tell you is you need to know where to go and find this information quickly if you want to pass the exam. If you want to use containers in production, you should know what is the use of startup probe and how does it help to make sure, right? This is what I was talking about, like 5 minutes, right? 30 into 10, and it is waiting for about 5 minutes to ensure your application starts up, right? Liveliness probe is kind of continuously checking the health of the pod, right? And oh yeah, one thing I wanted to make sure, if startup pro never succeeds, and the container is killed after 300 seconds, and after the subject, it is subject to restart policy. So what is restart policy now, right? So if we look at get deploy and nginx hyphen o YAML, and let's see, restart policy, always by default it is always. So if your container dies, and so your container was waiting for startup pro to succeed, but that didn't, it died, so it will automatically restart, it will restart that container, right? So that is what it means. Defining readiness probe, configuring probes. I would say please read through this. This is very helpful information, which will not only help you pass the exam, but also will be very helpful in your production use case, right? All right, moving on to the next topic. You can copy paste and run these commands, but I would say you should know where to go and find this information. Again, you don't need to search while you are following my content. You can just go and click on these links and you'll be able to kind of figure out, or it'll directly land you to pages, different pages, right? So this pod lifecycle, very important use case, which you should know if you are deploying containers in production, right? Then second is all these readiness, liveness, and startup probes, right? All right, next, moving on, workload auto scaling. Now, when I say auto scaling, by default in Kubernetes, what happens when you deploy something? If you recall, so I did this k get deploy, uh, k get deploy, right? So k delete deploy my deploy, and let's do it. K create deploy my deploy, let's say 2, k get deploy. So what did it do? It creates only one pod. It says how many pods it will have, only one by default when I deploy something new. Now, what if this pod is getting too much traffic? What if it is getting throttled? What if it is running out of memory, right? What's the solution? You can go and do k scale deployment, right? My deploy 2 hyphen hyphen replicas, let's say 3, right? So you could go very well do this, but what if you are sleeping and it's middle of night, you are getting a lot of traffic in your production environment, you don't want to do this manually, right? What's the solution? Solution is horizontal pod autoscaler and vertical pod autoscaler, right? This scales the number of pods based on CPU and memory and custom metrics. So how do you define it? Very easy. You just run command like this, right? So I don't have, let me see if I have, right? So yeah, so it created a autoscaler for my nginx deployment, because I just copy pasted. But if I, let's say k get hpa, you can see it says it shows unknown while it is still monitoring. It takes a moment to get the number. It'll say 0 1 or something like that. How many minimum pods you should have, how many maximum pods you should have, and CPU percent. I think CPU percent is getting deprecated. It says CPU, right? So you define like this, 70%, 50M, right? But what I'm trying to tell you is you can define CPU percent, you can define even your memory percent, right? So CPU, memory, and this is what kind of helps you to scale your pods up and down up to maximum 5 pods, right? What is the current count is 3. Minimum it can go to 1. If it doesn't have enough traffic, it'll go to 1 pod. Maximum it could go to 5, right? That is what it means. All right, so let's see what is next. Oh yes, to enable this, you need to have metric server configured in your cluster. I don't know if this one has it, because we just picked something from the internet, right? SKN uh, queue system. Get PO. Let's see. Do we have scheduler proxy API? No, we don't have metric server running on this one. So yeah, I don't know if it'll let me do that. Um, See, this is what I was talking about. You need to have metric server running for it to work. Why? Right? That's the question that comes into mind when I did this. It was showing something like this, right? It says unknown because there is nothing that is telling it how much is the CPU usage. So if I try to do this k top pod. See, it says metric API unavailable. So we'll have to deploy metric server, then only it'll work. During exam, you won't have to do it, but if you are um, kind of playing it in your environment, or you are doing it in your maybe office, right? In your work environment, development environment, then you might be able to use something like this. Now it is not able to start. So let's see, describe pod, and you can say metric server started, and it looks like it might be waiting for its readiness probe or something. Yeah, so this is what it is waiting for, container ready and all that, right? Anyways, that's not the topic here. I just wanted to kind of make sure you know that it needs API or metric server API to be available, right? Then if you want to know, you can always kind of read more about kubectl scale and hyphen hyphen help, right? That will give you information. Then next is vertical pod autoscaler, right? Vertical pod autoscaler um, is a, you can use it. It says experimental outside core Kubernetes, but I think I might have incorrect information there. I'll update it. So hold on, let's see, automatic workload scaling. Then I have something on horizontal pod autoscaler too. Okay, automatic pod autoscaling. So it is stable. So yes, I need to update my documentation there. And this is scaling workload is auto recreate initial. This is VPA cannot okay, VPA can operate in four different modes. One is uh, currently recreate, right? So uh, when we say vertical, right, horizontal means you your autoscaler is adding more number of parts based on CPU usage, memory usage, as I was talking about, right? With vertical pod autoscaler, it is kind of adding more resources rather than creating more copies of your containers or your pods, right, within a deployment. As we were doing here, we did the, you know we can, hold on, k describe HPA, and you can see something here. We were doing it on minimum, maximum, and deployment, right? So uh, this is what it means, right? For vertical, if your container has, let's say, two CPUs, you want to make it four. What's the solution? It will spin up a new container or new pod for you under that deployment, and then it'll delete the old one once new is healthy, right? That is how VPA works. You are assigning more resources. In case of horizontal, you are able to go wide and kind of scale out and scale in, versus vertical, you are scaling up and scaling down, right? Resources, your number of replicas don't change in case of vertical. In case of horizontal, it does change. That's the idea. There is a new type of scaling option now available, which is in place scaling. Very interesting one, I would say. Read through it, you're gonna like it. So I added a link for that: resize CPU memory resources assigned to containers. Read through it. It's very interesting. You are able to resize pod kind of on the fly, and this feature is in beta from 1.33, so it is enabled by default. I know EKS supports it because it is beta, it's enabled now. So what does it do? Basically, rather than recreating another pod for you, then moving your traffic to that, if you say my pod was running with the two CPUs, you want that pod to have four CPUs, it can do that now on the fly for you, right? That's the idea behind um, this new feature, right? How do you use it and all that? You use resize policy, and then you control whether container should restart or not. Read through it. Very interesting use case, and this is how you define within your pod to for your pod to either restart or not restart, right? In place CPU resize, right? If you want to restart on memory, then you can define it like this. It has some limitations. Read through it. I think I'll stop here. I'll cover config map. I will cover templating tools and secrets in my next video. We have covered understanding the deployment, self-healing options, right? The liveliness probe, readiness probe, and the startup probe. Then auto scaling, we looked into horizontal pod auto scaler, vertical and in place auto scaling. These two topics I'm going to defer for my next video. And if you have any questions, please comment on my YouTube, GitHub, or on my LinkedIn. I've listed some homework assignments. I would say please go through these and try to do it yourself. Um, Oh, yes, there are some hands-on tools available that I have listed here. Look at these tools. You're gonna like them. I'm planning to cover these during my next video, but if you want to kind of get ahead of my video, you are welcome to do that. Follow these links and you'll be able to kind of get access to the tools that I'm talking about. All right, take care. See you next time.